Hello folks, how are you all doing? It's Tuesday for some of you, Wednesday for some of you, and it's Friday for me, so it's all over the place, isn't it? Got a bit of bark going on in the background, so that's always lovely. We've got a fairly simple thing today in Arithmetic Series, but that means it's all the more important to make sure you do this work so that you're ready to smash the top marks out on it nice and easily and keep yourself some time for the other things so you don't have to think too hard about it. And before we do that, I thought we'd have a nice little puzzle, a little game of battleships to start us off. Right, well, you may feel tempted just to move on to the A-level stuff, which is fine if you want to, but I would urge you to have a go at this for two reasons. One, puzzles are a kind of game and games are kind of fun, but also in a puzzle you're always stuck with this position of trying to find a logical way forward and having to use your own brain to work out what's going on. And that's going to happen in the exam from time to time. It's not always about knowing the maths, but trying to work out what's going to be appropriate in this case. And sometimes, with all the fancy stuff we've taught you, sometimes a bit of logic and what people call common sense, although I think that's a misnomer because I don't think there's any such thing as common sense really. What I call common sense will be different to what you do. Anyway, well worth the thing. These, by the way, this comes from the weekend edition of the Eye, very cheap but reasonably good newspaper, so has a fairly balanced viewpoint, I think, as I'm sure you all would agree. Anyway, so they've got loads of puzzles in there and they all vary a bit. So the thing is, we have got some battleships that need to be put in here of different sizes. We've got 4 dots, 3 of them have been placed for us already, so I'm going to cross those out. And then we've got all of these other boats that need to go on there. And the clue we've got, well, the several clues we've got, is that wherever there's a number here, that's how many there are in that column. So I've done one of these before and I found that if I put all the bits where I knew there wouldn't be a boat in first of all, that helped my thinking later on. So I've got that. It also says that you can't have a boat touching another boat even diagonally, so there will be clear water round all of these. Now I'm not going to do the rest of this now. I'm going to show you my finished solution next time. So have a little go at it and see what you reckon, and then you can check yours against mine next time. You can also send me your own version too, that would be lovely. All of today's examples come from the Maths Genie worksheet, which I have uploaded for you, and we're going to do 3 questions from it, and then I would like you to carry on for good practice to do all of the others. Now the first question's a prove question, and you may need to look back at your notes to work out how to do that. I'm not too worried about that at the moment, so, and I don't want you to get worried if you can't see your way through that for now. You do need to be able to do these questions, particularly the last one that I do. Definitely want to make sure you can do that one. Right, so an arithmetic sequence is a linear sequence, so it's one that goes up in equal amounts, one that we used to do with something called the nth term. At A level, we have a slightly different formula instead of the nth term, and we're given in the formula booklet this here for the sum of all of the numbers in a series, and the other formula is just this little bit here from there. So you can either use an nth term or you can use that. To be honest, there's 2 ways you could work this out, and I'm going to show you both of them. So, you should have, by the way, by now had a go at seeing if you can do it on your own. Because if you can do it on your own, you don't need to listen to me blurt on. 3, 4. The 5th term is 5, 6, 7. The 8th term is negative 16. So what I know is that the common difference is happening 3 times to get from there to there. So we're going from 5 down to negative 16. So the difference between 5 and negative 16 is negative 21. If I divide that by 3, I get negative 7, and that is actually part B. Take 7, take 7, take 7, and I could work that out just to check. 5 take 7 is negative 2, then negative 9, and then negative 16. And to work out the first term of the sequence, I could just go back and say, right, I'm going to have 1, 2, 3, 4. I'm going to be adding going that way, aren't I? So 4 times 7 is 28. 28 plus 5 is 33. So 33 is the first term of the sequence. So that's how I would do it, because I like to just think things through for myself. However, if you're thinking, right, I want to go in there thinking arithmetic sequences, I can look in the formula booklet, and when I look in there and I see that it says the sum of the terms, and it gives you two different formulae actually, so let's talk about these at the same time. So in the formula booklet it says this, a plus L, and then it says equals a half, so that should say a half there, a half n square bracket 2a plus n take 1 d, and your formula for the nth term is going to be that a plus n minus 1 d, and a is the first term, n is the position in the sequence that you want to be, and d is the difference. And these two formulae tell you the sum, which we'll come on to more of later on. And there's an L there. The L is the last term. So if you know the beginning and the end of the sequence, and you know it goes up in equal steps, you just have to add those together and multiply it by how many you've got and halve it, and that will get you there. Right, so anyway, what was I going to say? You can use, and if you look in the textbooks, this is what it'll tell you to do. You can make a couple of simultaneous equations, because you could say, I know that the nth term is that bit there. So for this term here, we know that we've been told the fifth term of the sequence. So we know that 5 is equal to a, whatever that is, plus n take 1, so that's 1 less than, now it says the fifth term in the sequence, so we want the n take 1 will be 4d. And then for the 8th term, we've been told that the 8th term is negative 16, and that's also going to be a plus 8 take 1 is 7d. And now that you've done that, we can just solve simultaneous equations there. If I take the top one from the bottom one to find the difference between the two things, then the a's disappear, we end up with 3d there, and from 5 down to negative 16 is going down 21. So we divide by 3 and we get negative 7 again. Right, you join me here after I've made a bit of a mistake of the beginning bit. So there's your question. Pause it, have a go, and if you want to look at see if you can work out what my mistake is, if you like, and then I'm going to go through it in a moment anyway. Right, so a is 2.2, the first number. The difference between each one is 0.2. And so I've gone for going old-fashioned nth term as we would in GCSE time, but then I said that's going to equal 100. That's nonsense, of course. The 100 is what n is. In the 100th week, n will be 100. So I would do 100 times 0.2, which is 20 plus 2 equals 22 pounds. So that's the old style way of doing it. The new improved, slightly more complicated A-level formula being a plus n minus 1 d, we would use that and say we've got 2.2 plus 1 away from it. We want take 1 off it because the first week's already accounted for. We're then going to add 99 instead of 100 of these, because you've got the first week plus the other 99 weeks, times 0.2. Pop that into your calculator and you do indeed get 22. So £22 is the answer to the part A. Not very difficult for 3 marks, is it really, altogether? And then part B, looking in your formula booklet, you should have that the sum of all of them. Now, because we know that the final number until week 100, I think actually the nicest way to do this, I don't know how much he's, as I do know, he's getting £22 in the final week, isn't he? So because I know that, I'm going to use a half NA plus L. If you've used the other one, then that's absolutely fine. A half times it's 100, half times 100, and then the first week he gets £2.20, which is 2.2, and the last week he gets £22. Pop all of that into the calculator and you should get 1,210. If you didn't get that, then go back and check your numbers. If you had used the other formula, you would be which is a half n in brackets 2a plus n minus 1 d. So always be careful when you look in the formula booklet, when you're going for the nth term, you've got to take that 2 off. That's your nth term, and this is the sum of all of your terms. And for the first 100 terms, we would put in 100 there, and you'd have a half times 100. Open your brackets, you've got 2 times 2.2 plus 99 times, what's D, 0.2. Put all of that in and you also get 1,210. Right, the last question puts a few of these things together. So pause the video. Think about how you're going to take this on. First part, very similar to what we did the first time. So what we've got, let's think about it. In the first week, the factory produces 100 cars, so that is A equals 100. The number of cars will increase by 4 each time, so D equals 4, until the number of cars reaches 180. We want to know how many weeks it takes to reach 180. Well, if our formula for the nth term is A plus n minus 1 d, then we could do 100 plus n minus 1 d is equal to 180. If you wanted to do it by the nth term, it would be slightly different. I'll do that in a moment. So you'd have 100 plus, oh, we know that that is 4, don't we? Times 4 plus 4n, take 4 equals 180. 100 take 4 is 96. So if we take 96 away from both sides, we get 4n is, take 96, did I say? Yeah, so that will be 84. Divide by 4 and you get 21. Now if you want to go old school on it and do the nth term the GCSE way, then that's absolutely fine. In fact, it's a little bit simpler, because all you need to think about is it's going to be 4n, 4 plus 90, the first term is 100, yes, so 4 plus 96 is 100, and we want to get 180 as our result there. So the only difference is we're not going to have to expand that bracket. We take 96 away and we get 84, and we divide by 4 to get 21. So that's part A. Finding the total number of cars produced in the first 52 weeks. Well, we've got a two-part thing here. We've got the first 21 weeks, and if we use our sum of the series thing, sum to 21 is going to be a half times 21, and then this is a bit where you often misses. So make sure you really do look in each time. See that 2 in front of the A. 2 times the first term, which is 100, and then we don't want 20, we want the next 20, so it's 21 take 1 is 20, and it will be 21 times, oh, how many was that? That was 4, wasn't it? Because that was on there. And if you put all of that into the calculator, you get 2,982. But that's not the end of it, because you got 52 weeks altogether. So 52 take 21 is 31. We're going to be adding 31 times 180. So if you add 31 times 180 to that, you get 8,562, and that should be your final answer. Well, I hope you all enjoyed that, folks. So you've got a few more questions to have a go at, and then don't forget to show me what you've done. All right, have a good day. Bye bye.